Alrighty guys, this time we got a little bit better setup. Hopefully it's a little more comfortable to record. Hopefully everybody can hear me okay. If you can't hear me okay, please let me know. I'll talk a little bit at the end about what we got coming up, but I'm going to get right to it and try to keep these videos short and sweet and hopefully help you guys out as much as possible here this week. Alright, so we're starting with simplifying radicals. To start with, radicals are a square root sign. Okay, so in case you didn't know or were unsure what the word radicals meant, radicals stands for square roots. So just before we do an example, the square root of 25, for example, as we all probably know, the square root of 25 is 5. However, what we're going to do here is we're going to use the square root of 25. We're going to break this up, and the important part here is that I show you kind of how we get the square root of 25 into 5. So we could take 25 and basically make a factor tree and turn that into a 5 times a 5. Okay, and anytime we find a match under the radical, that is going to turn into just a 5. Okay, so that is the reason that works. So basically what we're doing here is we're going to be looking for matches to help break down and simplify the radicals. All right, so there's a good starting point. All right, for number 1, we got radical 56. Okay, so we're going to simplify this by trying to find matches. All right, so we take 56, and you can take whichever factors you want. It doesn't have to be 2 and 28. It can be that. For me, right off the top of my head, I think I've got 8 times 7. Okay, and then the 8 times 7, we can break that into, or sorry, it's still under the square root. And then 8, we can break down into a 4 and a 2. And then we still have the 7 that comes down. So what we're trying to do is break it down into and find any matches. So far we have no matches. So we can keep going. All of these are equal. We don't actually need that one up there. And then finally, here we get a pair of 2's. We got 2 times 2 times 2 times 7. All right, so this is under the radical. So that match is going to turn into a 2. And then we've got 2 times 7 that stays under the radical. That's radical 14. And so then this is going to be our answer, 2 radical 14. Which I know is a little bit different, but hopefully you guys get used to this. This week is something we're going to use with quadratics and solving quadratics. So there is 2 radical 14. That would be the simplified square root of radical 56. Okay? Now, I know I said this in the past, but at any point, if you need to pause the video to kind of catch up or to slow me down, go ahead and do that. I will try to keep things going so as to keep these videos shorter as possible, but feel free to pause at any point. All right, number 2. This time we have 5 radical 18. All right, so this time we have a number out front. That is a whole number. That's okay. The 18, we're going to split that up. So the 5 just stays out here. All right, and then under the square root, we can pick whichever factors of 18 that we want. I'm going to go with, a lot of times students, if it's even, they want to do just 2. So 2 and that number, that's totally fine. So we have no matches. For the 9, though, we can break that into a 3 and a 3. This 5 is still out here. So then what happens is we've got a pair of 3's. This is left over under the radical. So the 5 times the 3 goes here, and then the radical 2 goes there. So our final answer on this one, because this 5 out here is not just 3 radical 2, but 5 times the 3 is 15 radical 2, and that will be our answer. Okay? So there's number 2. And like I said, feel free to pause if at any spot you need me to slow down. Okay? All right, next one, number 3. We'll keep things going here. 4 radical 6 times 3 radical 14. All right, so this time we have 2 terms, but we're multiplying together. So anytime you're multiplying, we can combine all this together. And the 2 things under the radical, we'll show you how we can put that all under one radical. All right, so I would start with the 4 and the 3. Bring those out. 4 times 3 we know is 12. Okay, get those out of the way first. That way it's there. And then you can move on to the radical stuff. Now 6, I'm going to break that into a 2 times a 3. Okay, and then the 14, I'm going to split that one up into a 2 times a 7. Now notice I only put 1 radical there. All right, because anything that's under the radical, I can still rewrite it in this way, okay, with it all under one radical. All right, and so then we end up with 12. Now I've got a pair of 2's that link together, so the 2's are going to come out here. That becomes that 2. Now under the radical, I still have a 3 and a 7. Now there's no matches left. They're both prime numbers, so I just stop there and I just take 3 times the 7. Okay, and then I'm going to write my final answer is 24 radical 21. And there we go. Okay, so that would be our final answer for number 3. All right, I'm going to keep moving here. I know I've mentioned pausing it kind of in between each one. You can also feel free to send me an email to try to help you guys out. I'll talk a little bit about the end about the kind of situation we're in now, but we're going to make the most of it. So let's go ahead and keep moving. Now with number 4, this time we have some variables. So we got the square root of x to the 10th, y to the 13th. Okay, so we did 2 of them on here now for radicals with exponents. So if you recall, exponents have their own special set of rules. And so because of that, our rule for exponents is that we can take half of it, because the square root, it's not the square root of 10 that we're taking, it's the square root of x to the 10th. So forget about this one just for a second. So if I were looking for matches, and you don't have to do this every time, but if I were looking for matches, I can make this x to the 5th times x to the 5th, and then I have a pair of matches. But really, we don't have to write that step. We could just say, well, every time that it's an even number, we can just take half of that, and that will end up being our perfect square. So half of x to the 10th is x to the 5th. So that any even exponent, you can just take half of it. That's our rule, okay? Now, if it's an even exponent, it works great. But if it's an odd exponent like this one, we can't do that because we don't want to write y to the 6.5 power. We don't want any decimals for exponents. So what we're going to do, we're going to go ahead and we want to go to the closest even number, which the closest even number 13 would be 12. Okay, and so that means I still have to account for that one extra one, so that's y to the 1st. All right, I can't go over it because I can't create more y's than I have if I have y to the 13th. So what I'm going to do here is I get to the closest even exponent, and then I do the same thing I did here, so we can kind of skip. So the square root of y to the 12th is y to the 6th, so that's a perfect square. And then this one is a leftover, that's y to the 1st. So this ends up being our answer. So basically, this part we can kind of, you could skip, you can write it out if you want to keep looking for matches. We could write out y to the 6th times y to the 6th and then circle it and write it out front. Okay, so our rule for exponents is take half of it. So once you kind of get over just seeing the exponents in with a radical, that's kind of weird. But once you get over that, it's really pretty quick and simple. Like just, we could have a big number. If we say we had the square root of x to the 34th. What is the square root of that? Well, we don't have to worry about the square root of 34. We just take half of 34. That would be x to the 17th. Okay, just to show you kind of a sub example there of that one. Okay? All right, last one. Last one here. We got a combination of everything we've done so far. We've got 5 radical 49 x to the 5th. So the 5 is going to stay out here. 49, I can break that into 7 and 7. Okay, and then x to the 5th, I'm going to go one lower, x to the 4th. I still have an x to the 1st out there. So there's my breakdown. I've got a pair of 7's. So we get 5 times 7. X to the 4th is a perfect square, so we take half of the 4, we get x squared, and this one is left over, so that's the only thing left under the radical, and so our final answer we get 35 x squared radical x. So it's a little bit different with the kind of answers that we get on these. You can pause at any part if you feel like I moved too fast. Let me know if there's any kind of feedback or anything I can do better as far as getting you guys the information. Homework will go along with this or be very similar with a few review questions mixed in. One thing with us not being able to finish up the school year, obviously it's a very strange situation. We're all going to do the best we can. The main thing for you guys is that you got to understand we got to put in the work. Okay, there's no substitute. You can't go look up everything going into the test. You got to practice it. okay? And you got to do your best. And if you do try to take any shortcuts, that's going to come back and bite you at some point, because we're not going to be out of school forever. And we want to see you guys do the best you can with this. And you really want to make the most of it. You got to put in some effort, okay? I'm gonna do the best I can for you. If you're struggling with something, please let me know. Send me an email or a Canvas message, and I'll figure out a time I can help you out in some way or the other. Okay? So there you go. Simplifying radicals for Algebra 1, 2. Thank you guys, and hopefully a little bit better setup this time.